Da, da, da.
I think I'm as ready as I will ever be.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 322, Fake Hackaday Writers, New Retro Computers, and a Web Rant. This week in Hackaday News, fresh off the presses, Hackaday Supercon 2025 just been announced. It's always been the first weekend in November. This year, the first weekend in November starts on October 31st. So we will have possible Halloween shenanigans going on the first night of Supercon.
Gosh.
And, usual Supercon on Saturday and Sunday following that. So October 31st through November 2nd, Pasadena, California. But what I'm here to tell you is that the call for participation form is online right now. You have 6 weeks. We have opened up the call for talks and workshop submissions. For talks, we've got, as usual, short talks and long talks, 20-minute and 40-minute talks, respectively. So if you've got, just a simple project you want to discuss, or maybe you haven't given a talk before and you don't want the full limelight, absolutely submit a short talk. And if you've got something that you really want to dig into the meat of, our audience will love it. Give us a long talk.
Sounds good.
Yeah, it's going to be fun. We've got, as usual, both stages running. We'll try to cram in as many talks as we possibly can. Oh, other events in Hackaday News this week. An obituary for Ed Smylie, who is the NASA engineer who pulled off the duct tape hack that saved the Apollo 13 crew. Basically, they had a problem with their oxygen generator, and he made an adapter to go from one to the other. And it's the classic square peg in a round hole situation. And he came up with an adapter made out of plastic bags that they had on board used for clothing, cardboard from the flight plan, a spacesuit hose, and a roll of duct tape. Unfortunately, he passed away this week, but my favorite quote of his, this from a NASA engineer: if you're a Southern boy, if it moves and it's not supposed to, you use duct tape.
I love it.
Al Williams wrote up a piece on the history of duct tape once and pointed out that since that mission, there's always been duct tape aboard every U.S. space flight.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? This week is a sound reveal week. Last week we played a brand new sound for you to guess at. Tom Nardi failed to guess it. Let's give Jenny a try before we let you know what it is and roll off for the t-shirt.
Okay, I'm just going to load it up. Well, it's very obvious. You found a Delia Derbyshire recording.
Oh, not bad, not bad.
I mean, it sounds like electronic music of some variety, some kind of BBC radiophonic workshop sound effect from the 1970s, if I had to guess. But you're going to tell me it's something entirely different and, in fact, a machine for making things.
No, synthetic noise it is. It's Jerobeam Fenderson's oscilloscope music.
Wow.
And this is a section from, it's an old video of his where he shows you how it works, basically, and he's drawing mushrooms, squiggly wandering mushrooms.
Oh, of course.
Encoded in the audio that play off in the oscilloscope.
Oh, I should have recognized that.
I think a number of our listeners go check out their hunches before they submit them. But a number of people pointed out that this was probably the one showing dancing mushrooms, which I thought was pretty impressive.
Now, this reminds me, there is a Hackaday piece a few years ago. Somebody wrote a JavaScript in the browser oscilloscope image generator. And we set the challenge, can somebody adapt it to draw a wrencher? And somebody did. So if you look back through the archives of Hackaday, you will find a link to a paste bin type things, which has got some JavaScript for creating a wrencher in the browser. And it worked.
Oh, you're going to have to find that and dig it up and throw it in the show notes if you can. Well, there were 25 entries this week, and of them, 11 are correct. So let's see. 11. How am I going to do an 11-sided die? Let's see. This is one of those where I'm going to have to cheat.
Is there a 22-sided die?
And divide by 2.
Yeah.
I could just roll a 20-sided die until it comes up 1 to 11. No 20-sided dice around, though. All our dice are downstairs. I'm going to do the one where I take a picture of myself with my webcam and hash that, pull the random number from that. Here goes. Photo of me, hashed modulo 11, number is 8. Oh, and I
Cool.
add 1 to it because you have to add 1. Congratulations, Calculus. Oscilloscope music, more than likely showing dancing mushrooms. Absolutely correct.
We really need an official Hackaday random number generator, maybe deriving it from the hash of the most recent comment or something like that.
Oh, that's not a bad idea. Ooh, I'll do that for next week. or 2 weeks from now, I guess. But that's brilliant. Yeah, I'll just hash the Hackaday webpage. That's random.
Well, that would work. Yeah, that's cool. Yeah.
There's no way I can rig that. Not like I'm rigging these anyway. But it's fun to make it not riggable anyway.
Well, you're going to have to involve the 555 in there somewhere.
Oh, we should do that too. That's another one that's really great. Well, congrats, Calculus. I'll get in touch with you and get you a t-shirt. Everyone else, stay tuned for next week. We'll have a brand new sound. All right, my first hack comes from Tech Alter, and it's a little bit of a provocative title. His video was called 1 Month Without US Tech Giants. As Tyler August, who wrote this up, points out, it really ended up being 1 month with entirely open source software. And I think that's kind of more of the point here. This is really interesting because there's been this joke for a million years now about this year being the year of Linux on the desktop and, open source software being finally able to do everything you want. And, of course, there are a bunch of nerds, like probably both of your co-hosts, who don't use much or any proprietary software. I know that I use exactly none.
Yeah, same here.
And have for decades. So it's not weird to me, but I'm on the other end of some curve. TechAlter, on the other hand, seems to be on the, slightly nerdy side of mainstream, but significantly further in than your average Hackaday folks. And so it's really neat to see him going through all the different software and services that he uses to get work done for a month. And his big revelation was the Nextcloud platform, which gives you kind of cloud storage and calendars and work together with other people type productivity tools, and a lot of the stuff that people use the Google infrastructure for. And I thought that was pretty cool. He goes so far as to also get a phone that runs EOS, which is derivative of Lineage. It's an open source version of Android, but it's got a lot of good open source tools and apps with it that the kind of most stringent open source Android versions don't have. He uses a Tuxedo laptop, which comes pre-installed with Linux, blah, 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 blah. If you have been using open source software, the video itself isn't going to be that much of a revelation to you that you can get all your work done with open source software. I mean, well, duh. But on the other hand, if, you want a video to point your relatives to, or, even if you just want to see kind of what productivity apps he thinks are good, it's maybe worth a watch.
Well, it's certainly something that quite a few people have found themselves doing. Not really so much to ditch something from the USA, but maybe to ditch something associated with a particular software company or whichever. And you suddenly realise just how much so many of the competitors to a particular product rely on that product behind the scenes. So, for instance, search engines. You think there's a whole load of search engines out there. But when you look at them, you find that many of them actually use Google behind the scenes. I was doing this in particular to avoid Google's awful AI search interface. I know there's that hack you can do where you supply it with a query string variable and it gives a more clean interface, but I wanted to try all the others. And it was quite surprising that all the ones that were any good were basically Google, but skinned with somebody else's front end. And my eye was caught this week by Max1ZZZ, who has created an all-new ITX motherboard that implements a Mac Plus. The Mac Plus was actually a surprisingly simple machine, but it had one or two bits of slightly custom silicon. It had, I think, a Sony sound chip, which is unavailable, and it had a bunch of programmable logic devices. And what this board does is it brings together all of those pieces that have been re-implemented by open source community projects. So, for instance, somebody put a lot of effort into reverse engineering the programmable logic devices, and there's somebody who's created a VGA output for the Mac Plus that actually uses a Pi Pico. And what they've done is they brought together all the things on an ITX board, and it's all surface mount chips. So it's actually a lot less dense than the original Mac Plus board, similar ballpark size. The only thing he does that is original looking is he retains the massive, great big dual inline 68,000 footprint, mainly because he can use a ceramic package 68K, because sometimes came in a beautiful ceramic package with a big gold piece over the chip itself. And I can totally go with that because it is a very attractive chip if you have one. But it's interesting because it really highlights how a lot of these sort of more complex retro computers are now starting to be re-implemented by the community in terms of replacement parts for unobtainium parts. I mean, for a while, we've seen things like the ARM SID for the Commodore 64 SID, but I expect to see more of this kind of project over the next few years as more and more things become possible. As an Amiga user in the past, I would love to see something like this for the Amiga, but of course there already are the FPGA-based Amigas. And this links very, very neatly into another story that happened this week. There was a kanji, Japanese ROM for the Mac Plus, which was for years thought to have been lost. And somebody managed to turn one up and dumped it and has put it online. So if you make one of these all-new Mac Plus ITX motherboards, you can now run it in Japanese as well if you want to, which I think is very cool.
Yeah, I think you're absolutely right that this is going to be more and more of a trend as people reverse engineer more different parts of these old retro computers. I actually saw at Chaos Congress this winter, someone had managed to recreate an entire Commodore 64 using a bunch of Pico 2040 modules. Each of them took care of an individual subsystem of the old 64. So like where the 64 has like a video display chip, and then it has the audio chip, the SID that you mentioned, and then it's got the processor. Each one of these was kind of mimicked by a separate Pico 2040 board, and it was all done in software essentially. But then it was just a motherboard with a bunch of these little dev kits plugged into it, and it was really fantastic. And that's kind of the story here too, right? Is that everything has been emulated, everything has been reproduced, and so you can just kind of plug all the reproduced parts together, and then you have the whole. It's a marvelous and weird circumstance that we find ourselves in, that everybody has reproduced enough of the little bits that you can now build the whole thing.
Well, it's a good time to be alive. I mean, there was a time when the Mac Plus was an object of desire, and
right.
A 1 megabyte computer was quite something. And this thing comes out of the box with 4 megabytes, just without question. And we think that's small nowadays. That's actually a very, very high spec Mac Plus. So Breakout System 7.
Well, next up from me, as the world burns, at least you'll have secure messaging. Is the write-up of a project, The Communicateur by Bertrand Selva. On its face, it's kind of a simple Pi Pico-based LoRa radio communication device, except it has a really absolutely beautiful user interface, you have to say. But what got me interested in it was the geeky insides, which is its main trick is that it is able to communicate entirely encrypted with another device of its own kind that has the same SD card in it. And it's fun because it uses kind of the same idea as the Cold War red phone systems did. That is, it has a series of codes that change all the time. In this case, every 2 minutes. If you receive a communication from another one of them, you just have to look at what this 2-minute window's code is, and then you can decrypt the thing. The codes are, of course, pre-generated and entirely random, so you can't know what those are unless you have the same copy of the SD card in it. And you might think that eventually you just run out of randomness here, but he points out that with 256 byte keys every 2 minutes, it's actually very little data. It's 180K per day. And he claims that a 4 gigabyte SD card will last over 60 years. So there's no sense in reusing the old keys anyway. It doesn't fall to the rolling keys problem, which is if one radio or the other misses a transmission, they become desynced. And so they're no longer on the same hop in their long key table. If you just don't hear this one, well, 2 minutes later, you're still going to be on the right key again. It also, I guess it does rely on the clock staying in time, but with 2 minute sliding windows, it's probably not that big a deal. And the last cryptographically interesting trick this system brings is that it can delete the past keys every 2 minutes, and this provides backward secrecy. So if somebody eavesdrops on an old message but doesn't get to your device in time to get this current segment's key out of it, it gets overwritten in the memory and will never be decrypted again. It's kind of the perfect encryption scheme. If you dig deep enough into cryptography, I think the algorithms we have now are good enough that the only real problem left in cryptography is how you get the keys to the interested parties and how you handle them once they're there. And this one takes care of that very easily. You distribute the SD card, physically to the other person in their hand. So that's pretty much an easy to verify transaction. And then after that, they destroy themselves slowly over time. So it's a lovely, lovely little project. And I presume an entirely unnecessary degree of secrecy, but loads of fun.
I rather liked this project too. First of all, for an aesthetic reason, alongside that interface, it's got a lovely 3D printed case that looks really sort of retro 1970s, which is enough to make me want one anyway. But there's something else I noticed over the last couple of years with my random friends in the European hackerspace community. We've been doing Meshtastic, which is little LoRa modules and little microcontroller for messaging, not as secure as this. And as you travel around the continent, you discover that different countries favour different frequencies. And I noticed this one, he's given it a 435 megahertz LoRa module, whereas most other European countries use 868 megahertz, from which I'm guessing that he's in Belgium. Because for some reason the Belgians have gone for 435 megahertz, where everybody else has gone for the higher frequency. It's kind of silly because, of course, the lower frequency will go further, but perhaps everybody in all the other European countries just doesn't want their Meshtastic or LoRa messages to go so far. It's just a little sort of observation that I've made over the past couple of years. I guess something to choose when you ever build a LoRa thing. I believe Americans don't have such a choice, do you? Or, of course, no, Americans will have the 435 because it's the amateur band. Is it 915?
Europe's on 868, America's on 915.
Yeah.
They're the same modules in the end. The manufacturers of these modules have had it up to here, and they just put a wide filter on it that covers both of them, and you can switch between in software.
But sorry, Americans, you can't talk to us Europeans.
I mean, this device isn't aiming to be interoperable with anyone else's anything anyway, right? It's like this is strictly the encrypted point-to-point red phone device, but I know what you mean.
So it's just a little observation from traveling around Europe with a Meshtastic node.
Oh, funny. Does anyone make a dual band Meshtastic node where you just throw 2 LoRa modules in there and then you can talk on both?
I'm sure somebody must, but I haven't seen one. Then again, I haven't really looked.
That'd be a fun project.
I was really intrigued by Andrew Sonnenberg's project. He has designed an open source high-speed Ethernet switch. Now, if you know how a switch works, it's basically a traffic routing system for Ethernet packets. And at a basic level, it's reasonably easier to understand what it does. And I'm guessing that many Hackaday readers could write a simple algorithm that would do that. And if you had a very slow set of Ethernet connections, you could probably make some form of switch. Where switches become difficult to make and why high-end switches are very expensive is that when you're dealing with gigabit or 10 gigabit or whatever Ethernet connections, you have a vast amount of data coming through. And what he's done is take on designing an open source Ethernet switch which is able to handle that crazy amount of data. Part of his description is dealing with the slightly exotic chips that he ended up with. First of all, they had no data because their manufacturer notoriously didn't release data. But then the manufacturer was taken over by, I think, was it Microchip or somebody who did release the data. And then he was looking for a suitably quick FPGA to drive it all. And he ended up with a very expensive FPGA, very cheap on Ali, as often is the case. But simply taking on this project and doing it over several years, quite a few years, is an impressive level of dedication. I appreciate I will probably never run one of these switches. I will always end up buying whatever little switch, TP-Link or whatever is reasonably priced. But I'm deeply impressed that somebody has gone to this level of detail in designing an open source switch.
Yeah, I follow Andrew Zonenberg's work on the social medias, and he is always doing absolutely insane high-frequency engineering projects. And this is one of the more impressive of them. Like, you started off saying that I could imagine how to make an Ethernet switch. I'm not even sure I could, but I am 100% sure that I couldn't even begin to deal with the high-frequency design stuff that borders on radar to get 10 gigabit ports, and for not even to mention 48 of them into a switch. I mean, the level of high-speed engineering here is just absolutely fantastic. And it's so cool that he's doing it all open source. For me anyway, it's the kind of thing where I can look over his shoulder and learn a lot about what it would take to do something this difficult. And if anything, you walk away with, more appreciation for the gear you've got in your own living room.
I should say, in my defense, I can imagine how the algorithm for such a switch works. And I'm sure given time, I could write an approximation to it, but it wouldn't be anything like this.
Yeah. All right, well, my last hack this week is Ivan Swarovski's The Mouse language running on Arduino. And this is a port to the AVR, the old school Arduino platform of the computer language mouse. And I had never heard of this. And so what was most interesting to me about this project was not that a computer language I'd never heard of was ported to the old school Arduino, but looking into this computer language that I'd never heard of. And mouse is really interesting. It's a stack-based programming language. It's actually tremendously similar to Forth, if you know what that's like. And kind of back in the old days, the 70s, people were interacting with computers much more interactively. Like program languages like BASIC come with a shell. You can run them interpreted like you can, say, Python, instead of purely in compiled mode like you do with C. And mouse is one of those languages. If anything, it's kind of like a stripped down version of Forth. It's a simpler version of Forth. It lets you type in kind of macros and run them. It's got all the math you need. It's got prints. It's got loops. It's got, break and return and things like that. So, you can do all the kind of programmy things you want to do. It's got an incredibly terse notation, which actually I spent 2-3 years doing Forth on microcontrollers pretty much exclusively. I'm over it now, but it was a really great time. Gave me a real appreciation for these kind of tiny little embedded / interpreted languages. And I love that loops in the language are just defined by parentheses. So you give it the number of times you want it to do the loop, and then you just put whatever it is you want to loop in parentheses after that. It has a bunch of things. Conditionals, the if-thens are just the square brackets. So if the thing before the square brackets evaluates to true, it does whatever's in the square brackets, and it doesn't otherwise. It's just a really cute little programming language. But then I went to look into the history of it and actually was tipped off by the inimitable Ken Boak, who in our comment section pointed off to an article about the mouse language's developer, Peter Grogono. And it turns out that mouse was an offshoot of a musical programming language that Peter wrote for the PDP-8 when he was kind of the resident tech genius at the EMS studio in London. And Electronic Music Studios is one of the first kind of computer music studios and gave birth to some of the craziest early synthesizers and just is an incredibly storied place on its own. headed by eclectic genius Peter Zinoviev. I mean, that was an insane place. And so the fact that this mouse language came out of that is even more lovely to me. And I appreciate Ivan porting it over to something as kind of pedestrian as the old school Arduino Uno. I think that's fun too. But if you haven't played around with these little kind of interactive embedded languages, this would be a good way to do it. I know there are some fourth languages for the AVR platform, but they honestly run better when you have a lot more RAM. And so there are better versions for things like the STMs and the ESP series chips, which just frankly have a little bit more RAM. These days, once you start getting up there, you might as well just give in and do MicroPython. Blasphemy. Even though it's not as fast.
What I like about these types of languages is just how little space they fit in. These are from the days when if you had 16K of memory in a microcomputer, it had a lot of memory.
Oh, yeah.
And so, what did this 4K or something it fits in? It's tiny. It's certainly a blast from the past for me, having started with a Sinclair ZX81 with 8K of ROM and 1K of RAM.
Yeah, the thing about these like super early computer languages, especially the interactive ones, is that if you read through the code that implements them, it's actually really neat to see how you could write this kind of super low level interactive system. I mean, Forth is just a bizarro language because in some ways it's like writing assembly language, but it's like writing assembly language in an environment that lets you both run things live and has an embedded code editor and like all sorts of other kind of, modern conveniences, right? But then the language itself, having to do all the stack stuff yourself and having a language that doesn't implement much that's too much higher level, than a lot of assembly language is an interesting experience. And I think this mouse is like that too. If you haven't played around with those, this sounds like a great one to try.
Yeah, BASIC certainly wasn't as efficient as a stack-based language.
Yeah, I mean, Forth, when you write it right, can go like a bat out of hell. And that's where the comparison with MicroPython, I guess, does fall down. Both have a REPL, but well-written Forth runs at, machine language speed almost. It can really haul butt. But that's at a cost. And the cost is, for instance, not using lots of variables because fetching things out of memory takes time. If you avoid that entirely, man, the CPU just gets to chunk.
If you cast your mind back to the early 1990s, there were a load of platforms like the Amiga and the Atari ST, all the 16-bit computers, and they were suddenly old hat with the arrival of one game. id Software's Doom came out, and it could run on a PC, but it couldn't run on the 16-bit systems. Overnight, nobody wanted an Amiga, nobody wanted an Atari, and those platforms sort of withered away and died over the 90s. I know technically you can still buy an Amiga, but in reality, they went away. It's often been said, you couldn't possibly run Doom on a 16-bit machine, but somebody has done the impossible. They have made a port of original Doom for the Atari ST. Now, it's not perfect. It runs on an original Atari ST, but at an unplayably slow level. But it's thought that there are many more optimizations that can be done. What they did was they went through the code, removed and replaced a lot of very, very PC-specific parts. And as I understand it, used a very optimized compiler to make the most efficient they could. But even then, it's not as optimized as possible. But the fact is, it runs on an ST, the one with the original 68,000, not a sort of updated higher range 68K series chip. This is the game we all wanted in 1993. All the people who had Amigas and had been saying for years, my Amiga is better than your PC, suddenly had nothing to counter with. And this is the game that would have gone down a storm in 1993. As a former Amiga user, which I keep mentioning, I would love to see the same thing ported to that platform, but it's still incredibly impressive that somebody's managed to get Doom at all to run on a 16-bit Atari ST, and I take my hat off to them.
I'm looking at the video now. Two things are striking. One is how good the graphics look. A lot of Doom ports these days, Doom on your toothbrush, Doom on your whatever.
Yeah.
The screen is the limiting factor. Here, the graphics look absolutely fantastic.
Yeah.
But it is dog slow. I think
Oh, yes.
this is a
Yeah.
frame updating. Does he say what the frame rate is? Because
It's
it
in
looks like
seconds.
I was going to say it looks like a frame a second or something.
Yeah, yeah. But they reckon that there is scope enough for further optimization that it might be possible to make it playable. I believe it has no sound at the moment either, but it's reckoned to be close enough that it might be possible. And it's running on the hardware. I mean, for instance, we've all seen the SNES cartridge. That's a stick it in, it plays Doom. And of course, hiding in the SNES cartridge is a Raspberry Pi Zero. But no, this is a real ST running actual Doom, which would have blown people's minds in 1993, I think.
I wanted to start off first with a student project from Willow, PentaPico, a Pico cluster for image convolution. And this is really cool. It was a student project. Willow builds a 5 Pico system where 1 is the master and 4 are basically compute nodes to do graphical convolution, which should be really easy because each chunk of the image can be processed separately. So the whole project is, take the image, split it up into bits, send those out to the 4 processor units, collect the data back together and put it together. What they find out here is that the hard part of doing distributed computing like this is often actually just shuttling the data around, and it ends up being slower. But I mean, A, the fact that Willow managed to get this working, and B, the fact that Willow managed to get this working well enough to come to kind of this crucial realization of cluster computing is absolutely marvelous. And it's a project that's well worth your time looking at. Next up, projects in flight, designing a hobbyist semiconductor dopant. From a kind of simple but well-executed project to an incredibly long-term project. Projects in Flight is trying to make a complete semiconductor fab process that is not just doable at home, but doable at home safely and environmentally friendly, which is, in the video, mentions Superfund sites that used to be Fairchild Semiconductor plants and says that's not the direction he's going. The issue addressed in this video is how to dope silicon with the P and the N's using, instead of the terrifying chemicals that get used in production, using simple boric acid and phosphoric acid for the boron and phosphorus, respectively. The trick is then to bake this onto the silicon so that it diffuses into the silicon in a high temperature chip oven. Getting the surface uniformly covered is hard. To do that professionally, they use special dopants that turn to glass when you heat them up high enough, so it protects the silicon underneath so it doesn't oxidize while it's in this furnace. Anyway, the whole point of this is that dopant stuff costs kind of $1,500 a vial, and Projects in Flight is managing to make a workable clone of this for hobbyist use that costs like $10. If you've never played around with tetraethyl orthosilicate, now's your chance. But it's a marvelous video and provides insight into only one phase of the semiconductor manufacturing. Next up is a really neat one if you're into reverse engineering printed circuit boards. This is Laced, peeling back PCB layers with chemical etching and a laser. Lorenzo Brodezzo has a process here which involves 3 different stages. So lye to take off the kind of solder mask and whatever, hydrochloric acid etching solution basically to take off the copper, followed by a laser pass, and then repeat as necessary. What's nice about this procedure is that the laser doesn't attack the copper and the hydrochloric doesn't attack the epoxy. So you can work your way down through a multi-layer PCB without messing up the layer below it, as you would if you were doing, say, a grinding based technique or an etching based technique. This is a really neat process and, fairly simple, easy to get chemicals, and neat because you don't risk messing up the layer below the one you're trying to remove. And last up, MCP Blender add-on lets AI take the wheel and wield the tools. If you haven't heard about MCP, you will soon. This is kind of a new, interesting advance in the LLM saga. It's basically an open protocol, that's the P, to allow LLMs to work with software running on your computer. And so MCP is the kind of go-between. And this one's about the write-up for a Blender MCP add-on. But right now there are, thousands, I think, of MCP add-ons being written for all sorts of various pieces of software. The one that is most impressive to me and also most absolutely reckless and dangerous seeming is one that is an MCP to Linux console add-on. So you can have an LLM just type whatever the heck it feels like straight into your terminal running on your computer. The Blender one actually works pretty well, and I've seen some demos of it where it's interactive and you can say, no, that square's too square, or how do you do this and that. Blender's hard to use, but there's extremely good online documentation out there. So the AI, of course, has ingested this online documentation and most of the time knows what the right thing to do is. Anyway, this is a really interesting new development, maybe the last 6 months, I guess, based on a lot of work from Anthropic. If you're interested in seeing kind of what the new hotness in LLM style AIs is, I bet you MCP will be in the headlines in the future.
Well, starting my quick hacks with one from Nick Build. If you remember back in the 1990s or early 2000s, there were a lot of also ran PDAs. These were devices usually sold in the back of Sunday newspapers and the like, which promised all the advantages of the digital lifestyle, but were not the PDAs that you get from Palm or whoever. They were in fact poor imitations with only one or two functions, but they looked cool. They had an LCD screen and a QWERTY keyboard. And what he's done is he's got one of these, which is an address book and organizer. They usually have things like dictionaries and other stuff. And he's tried to make it into something useful. And he's actually made it a very slow and unwieldy interface for an LLM running on a Raspberry Pi. But what he did was he reverse engineered its serial protocol for talking to a Windows 95 app, which is how it backed up to a PC, which was rather arcane for some unknown reason. It required a bit of figuring out. And then he uses the backup functionality to swap very small text files, which become the prompts and replies from the LLM. I hate these things. They're horrible pieces of kit. You'll often see them in secondhand stores, and they are no use to man or beast. But I'm kind of impressed by his persistence in making one of these do something useful. Playduino had an article how you can speed up the old-fashioned Arduino Uno 40 times by clever coding, and it turns out that digital write is somewhat slow in its operation, and if you sort of delve down to a lower level and do it closer to the metal, it's a lot quicker. I strongly suspect that if you're using an Arduino Uno or equivalent in 2025, you're not so worried about speed, but it's certainly interesting nevertheless. What it doesn't explain is whether the same applies to other platforms using the Arduino IDE. So, for instance, sometimes I will use the Arduino IDE to write for the ESP32 or something like that. I've never noticed that my waggling pins on ESP32 to be slow, but perhaps there's room for improvement there too. Be interesting to find out. Darcy J has a little project. It's nothing special. You'll have seen one before, but I thought it was rather cool. And especially good for long-time Hackaday readers, it uses a 555. The stylophone was the electronic music toy from the 60s and 70s. It's a PCB with a little oscillator on it and a load of different PCB pads and a bit of wire with a stylus. And you press the stylus to individual pads and it plays a note. It's a little electric organ. And it's very simple. It's an oscillator, RC oscillator, with each pad connected to a different set of resistor capacitor. Usually there's another oscillator in there that provides a tremolo and then a little amplifier for the speaker. And he's made a stylophone. It's rather a nice one, and I couldn't resist featuring it here just because I like it. And finally, Scott Ujan has made a portable M4 Mac Mini. Now, this is a fairly current base-level desktop Mac. It's a cyberdeck, But what I like about it is that it's a very nice take on a cyberdeck. It could almost be a product in its own right. He's taking a keyboard, stuck the Mac Mini plugging into the side of it, sort of, with a sort of fairly sort of wide display, similar form factor to the keyboard, that folds over the keyboard. There were some laptops used to have that kind of form factor back in the day. I certainly remember there was an Amstrad laptop had that, where it was a sort of long, thin thing with a full-size keyboard, and the screen sort of flipped up on the left-hand side of it. This is a modern take on the idea for a cyberdeck. Some cyberdecks are a little lashed together, but this one looks like it could almost be a product, and I really liked it for that.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to cover Maya Pasha's The World Wide Web and the Death of Graceful Degradation. And this is a full-on rant about the state of the internet today, and I love it. It used to be, back in the early 2000s maybe, graceful degradation was an important concern for web designers. And that is, if the particular browser you were using couldn't render the page the way you wanted it to render, you would at least have it render acceptably for that person. Because there were a whole bunch of browsers and they all had different capabilities. And if you wanted a website to be seeable by as many people as you could, you would code around this and you would use either a minimum set of features, or if you were going to use fancy features, you would have workarounds for them to work on browsers for people who couldn't support them. In the just pre-graceful degradation days, there was a horrible time where one website would be coded for, version whatever of Internet Explorer and wouldn't work on other browsers.
Yes.
And, they all had their funny little quirks and stuff. And so then things became standardized, and the kind of runs on everything web that we appreciate today was just kind of getting built up. And Maya's claim here is that because I think largely of incredible dominance of Chrome these days, the incentives for developers to make sure that their websites run on various browsers has slowly chunked away. And as the dominant browser kind of stops obeying written standards and starts implementing their own stuff, which then becomes a de facto standard, which is, I guess, fine. But then de facto standards are always evolving and you can't plan around them. This makes this very hard for web developers. On one side, gives the web developers no incentive to write their web code so that it runs on everybody's browser. And on the other hand, makes this moving target. So it's really hard for them to do so at the same time. And on yet a third hand, I think, provides them with all these shiny new toys that they can make their website look flash and gee whizzy with. And I think that pressure on web developers is forcing the modern internet to no longer be renderable on strange browsers, fringe browsers, heck, even a Chrome that's a few versions old. Like, I've run into web pages that won't run, and I'm using a Chromium based browser, but it may not be Chrome. And some websites do stupid things like just ask your browser what it is and then refuse to run on it if it gives the wrong answer. And that's just an affront. What I certainly agree with in Maya's rant here is that it's changed from a people writing the web try to serve to you have to go and download this version of this browser to use this website. And so it's like, put the burden of being nice off of the web developers and onto us. I agree with Maya's outrage at that, and I totally hear it. She also mentions JavaScript in here and how, can require different versions of JavaScript and stuff like that. But I honestly think that that's a little bit of a red herring. I mean, I appreciate that HTML as a strictly markup language, as kind of embellishings around text makes a ton of sense. And that, of course, is easily readable by everything and kind of a lowest common denominator way of communicating information. But websites are so far beyond text these days. They do stuff. And the doing stuff requires a programming language, and JavaScript is kind of the programming language of the internet. I mean, when you go to a website like Hackaday, you're there to read the stuff we write. And for that, I totally agree that HTML is sufficient. But like, you go to websites to play video games, or you go to websites to do crazy interactive stuff, or, there's all sorts of reasons to have code running in web pages as well. And I, also totally appreciate that. But what I absolutely agree with her with, though, is this kind of sadness that web developers feel emboldened by Chrome's monopoly over the browser space to say, any kind of compatibility problems, that's on you, the user.
This is definitely something we followed quite a few times, desperately trying to look at and review new browsers and different browser engines. But yes, the dominance of Chrome is just so unassailable. It's like being back in 2007 with Microsoft Internet Explorer. I will say to the JavaScript critique, it's nothing to the JavaScript hell you lived in around the millennium, where nominally everything ran JavaScript, but the JavaScripts they all ran were so different that you had to have effectively write the same piece several times normally to get it to work on Netscape and Explorer and whatever else. Fun times.
I knew this would trigger you. The thing I'm interested in, and I always worry a little bit about, is what these kind of making everything on the internet dynamic does to its archivability. And
Yes.
like, we end up using the Wayback Machine for a lot of things here on Hackaday, because Hackaday's been around for almost 21 years now. We've written up interesting hacks 18 years ago that you might want to see. And it's not always the case that those web pages are still there. I mean, it was hosted on GeoCities or something. Also, videos are going away. I've seen a lot of videos that used to be hosted on YouTube falling off as they've started to expire, I guess, some older accounts. And that's a horrible bummer. But web pages that ran JavaScript back then, if they're not backed up right, and if they aren't supported by a JavaScript interpreter that can run their old dialect of JavaScript back then, it really seems like a bummer to me. And I don't know how. I actually would be interested in reading. I should probably go look up how Internet Archive deals with this, because the JavaScript language has gone through a bunch of different revisions. How is it that an old version of it would be able to run today? And I know some of this happened with Macromedia Flash. There used to be tons of web content written in Flash, and then Flash ceased to exist. And now to view some of that old stuff, you have to have a Flash emulator running in something. And it's really kind of sad to see art and content and thought and ideas wrapped up in computing languages like this that then become obsolete and unsupported. And so, I don't give two about Flash, but I absolutely care about Homestar Runner, which is written in Flash. And so you need Flash to see Homestar Runner.
Yeah.
Future generations don't need Macromedia Flash, but they absolutely need StrongBad.
The JavaScript Flash emulators are surprisingly good. I know that for fairly static, web scraping, it's quite normal now to use effectively a browser engine to render the page and then grab that.
Yeah.
Not that I would do anything as naughty.
Well, I think that must be how Internet Archive does it.
Well, my can't miss is, in a slightly naughty turn, was one of mine, but it's one that's interesting enough. I want to discuss it here. ChatGPT, like other large language models, has a huge corpus of data that it builds its responses from. So they go out and they grab everything they can find off the web. There are all sorts of dubious legalities and copyright issues around that, which many courts of law are looking into. So that's not what I'm going to talk about now. But from that corpus, it can make stuff that's very like what it's found. And in particular, if you go to ChatGPT and you say, write me a thing, whatever that thing may be, in the voice of Hackaday's Jenny list or of the Hackaday writer Jenny list, you will get something that has a passable resemblance to my writing, because I've been writing for Hackaday for nearly 10 years now and many thousands of articles. So it's got a huge amount of my writing to work with, so it can make a pretty good stab. You can do the same with one of my colleagues. So, for instance, Al Williams, you can ask to write in the style of Hackaday writer Al Williams. And if you write the same thing side by side in my voice or Al's voice, they come out very different. And yes, the Al version sounds more like Al. you can basically emulate me. You could have all sorts of naughty things, write a ransom note in the voice of Jenny List so they will arrest Jenny List and not you, that kind of thing. What I find interesting is both what it's done and what it hasn't done. So I think I threw it at the returning Soviet Venus probe story. It was a story from the week before when I'd written it. It did a pretty good job. It got my wordiness. It got some of my British vocabulary, some of my slightly irreverent vocabulary too. So it did quite a good job of my style. What it did was, though, you could tell it was just summarizing what it had. So it was a lot of sort of facts and figures. It's going to enter the atmosphere at X kilometers per hour at angle Y and whatever, that kind of stuff. But it didn't manage to infer properly. It wasn't, I think when I wrote it, I was sort of wondering that if it lands, who will own it? For instance, will it still be the property of the Soviet space people, or will it be, marine salvage laws apply, that kind of thing? And of course, it did none of that. I could see that it wasn't written by me because it had far too many facts and figures. I tend to try and leave the facts and figures to the linked piece. So the idea is that you will click on and you will read the page with the hack on it, and it will have all the information. We're not there to tell you all the information. We're there to whet your appetite and say, hey, look at this cool thing. So it had way too much facts and figures, and it didn't infer. It was a very interesting exercise, though, in seeing how close it can get to a human and how it misses out on the human bit that the human writes. In summary, as I talk to my editor Elliot here, you still need a human to write things.
Yeah, we absolutely do. For just that reason, that you write interesting stuff. We prefer
Thank
you
you
to write it than the machines. I went, and as I would do with real Jenny List, I went and fact checked it to see if it made any sense with some of the things it's saying, because like you said, it did put out a bunch of numbers. What's interesting is that it clearly pulls from the webpage that your original write-up of this listed.
That's actually, to be fair, I should have said that's what I did. I said,
did you feed it that webpage as a source?
I gave it the web page as a source. I didn't.
Good.
I knew that it would hallucinate if I just told it to sort of think it up. The exercise was not to see whether it could find the stuff, but to see how well it could pretend it was me. So I gave it the link. So my apologies there. Yeah.
No. Well, so what's interesting is it completely plagiarizes one sentence straight out of that. And this is the sentence about the orbital inclination of 51.95 degrees. The reentry can occur between a latitude of 52 north and 52 south. It says exactly the same thing, except it says it could come down anywhere between 52 north and 52 south. And so it's like, it's doing this kind of cheap paraphrasing that, you would never do. And is, frankly, I would scold our writers for doing that. But then the other thing it does is it makes up some crazy number. And I don't understand how that happened. The orbit had decayed to a precarious 232 by 136 kilometers. First of all, Hackaday style is to say 232 kilometers by 136 kilometers. And yes. Second, what does that even mean? Like, I don't know what one number times another number means there, and I would hope a human would realize that a fellow human wouldn't understand that and would explain it. But then I went scrolling through this post to see where the heck it got that number from, and the number it has, let me see if I can find it again. The author of this post says that it fell down to 166 by 120 kilometer orbit. So the numbers are entirely different, and I still don't know what it means, but that's because the person writing this knows something about orbits that I don't. And
I have to say I'm not an orbital mathematics specialist either.
That's to be expected. But it gets the numbers entirely wrong, even though I know where it got them from. That's a little bit sad too, I thought. But I did like the, it'll finally come home with a bang, and it's finally coming back to Earth, whether we're ready or not. And I agree with you that this does sound like the sort of, witty little bits that Jenny List would throw in there. And so I am stoked that it pulled up that part of your writing, right?
It did Al in a similar way. It captured the way Al writes. The fake Al was very much like the real Al and very different from the fake Jenny. I would be interested to see and I haven't really got time to do this, but to go through the different Hackaday writers and see how few posts you need before it's not very good at writing in your style.
Oh,
because
right,
both Al
yeah.
and I have thousands.
Yeah.
But, we've had many writers over the years, and some have less, and some have not many at all. And just see how few you need.
I do think it's fun. In some sense, we're kind of low-hanging fruit because we've all written so many things, and so it's very easy for it to just find you out there. But it's still fairly impressive that it does work so well.
What I didn't try, of course, was ask it to write a fairy tale about a handsome prince in the style of Hackaday's Jenny List. Or something completely different, completely off topic for Hackaday. Perhaps I should have done.
There are things they're very good at, like producing text, and then there are things they're not good at. Really lovely to poke at the edges. That's also something that kind of came out of this piece, is to see what it gets right, but also notice the six-fingered hand.
In summary, listeners, Hackaday is still refreshingly meat-based.
And will be forever. Someone on Mastodon posted today that they had the feeling that a lot of this AI hype is like the radium hype after radium was newly developed.
Yes.
And A, being put into everything where it doesn't belong, and B, claiming to be in things where it obviously wasn't. And, so there was no radium in radium butter. And that's a damn good thing. And
Yes.
there's no AI in Hackaday, and that's also a damn good thing. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you have something that we should write up, send it to us at the tips line, tips@hackaday.com. And to follow all the links we mentioned in the show, head on over to hackaday.com/podcast. And until next week.
Eat, sleep, hack, repeat.
Yes, indeed. Yes, indeed.
Oh, yes.
I'm running out of sound ideas entirely.
Have I lost you again? Damn it, I've lost you again.
Excuse me, I'm burping. Who did this one? Why don't I have a name?
The web ain't what it used to be. I blame the youth of today.
Voila.
I hope that I wake up tomorrow morning and find Hackaday still reassuringly there.